Hello, this is John Clark, and I'm going to go through Assignment 0602. First, I'm going to start out with a brief review of the program logic, and then I'll display the results. I'll begin with the main function. In order to get this to work with the recursion, I created 4 global variables, one for the visited table, one for the dictionary of words and word counts, one for the number of pages processed, and one that is a self-imposed page limit for processing. I wasn't able to get this to work on the CDM site at all, even the first time running it with the 10-page limit. Anyway, I ended up running it against the law school site, which did work. The first thing I did was I increased the recursion limit, since the default values caused the program to fail after a few thousand pages. Then I executed the web crawl. Next, sorted the dictionary by word count, and finally printed the results. The web crawl function basically looks like what the professor went through in class. The only difference is that I added conditions to reduce the scope of sites to be looked at. It seems the DePaul sites are all connected to each other. At one point, the program went down a rabbit hole of dormitory calendars for thousands and thousands of pages, for example. Next, I have the analyze function that opens the web page and analyzes the content, which includes getting the links and putting them in a table, and then invoking the HTML to text conversion. The results for the one page, the parsing, come in as a text string, which is then decomposed into the page word table function and placed into a table. That's then passed to the frequency function, which sorts and counts the words in the table and does a little bit of additional scrubbing. Scanning through the page word table function, used text split, and also eliminated common words like of, if, to, and some miscellaneous things that weren't words. Frequency pulls in the words on the page, sorts them, then counts them, and places them into a global dictionary that stores the words and the word counts. There is a small function after that which sorts the dictionary, and after that I print the results. Moving on to the parser itself, classes, init is modified to create to support the links and the text table. And then I have extensions for get links, handle start end tag, handle end tag, handle data, and created a new one called obtain text, which returns back a string to the rest of the program. If I had to do it over again, I would push more logic into the methods for the classes, which have increased efficiency and simplified the program logic, but this is where I ended up. As to the output, I had some difficulty getting this to run to completion. The program ran very slow at certain times of the day, especially at night. Added to that, the various DePaul websites all seem connected to each other, which I began weeding out, but I ran out of time. I confirmed that the program was not visiting any page more than once through extensive testing of it, but at the end, my most successful run was this morning, which you see here, where I analyzed 30,000 pages. I ended up at the DePaul Museum site, which appears when the program hit the 30,000 counter that I never thought I would hit. You can see some of the words, collections, artist, things like that would be, common to the museum. So that's basically it. End of explanation.